Welcome everyone to the last Jigsaw talk of the day. This is Advanced Modular Development. My name is Alex Buckley. I'm in the Java Platform Group at Oracle. I do the first half of this talk, and then my colleague Alan Bateman does the second half. Mark is here for emotional support. This is, believe it or not, even though it's the end of the day, this is the third of 5 Jigsaw talks. Alan will have the dates and times of these at the end of the presentation, but modules and services and Project Jigsaw Under the Hood are tomorrow in this room. And then we also start the repeats of the whole cycle with Prepare for JDK 9. I think that's on Wednesday. Does that start getting repeated tomorrow? So anyway, this talk is in 2 parts, and they're really both about migration because there's a whole module system API. You can look at the Java doc for that. But the first and most existential question when modularizing an application for JDK 9 is where did the modules come from? And that's really what this talk is about. So I'm going to talk about migrating your application top down. And then Alan will speak about migrating libraries that sit closer to the JDK than your application. So that's bottom-up migration. So application migration. At heart, a typical application has 3 layers. At the top are your jar files. At the bottom is the JDK. And in the middle of this sandwich is the filling. A bunch of jars downloaded from the internet in the nicest possible way, and thrown on your class path. In Project Jigsaw, we've turned the JDK into modules, such as Java Base, Java Logging, Java SQL, and Java XML. Modules are good things. They're always in green. Their benefits are strong encapsulation, so that no one outside a module can access its internals, and reliable configuration, so modules know what they need and there's no need to set the class path. If this sounds good, you might be wondering how to turn your application into modules. Let's put some names on the jars at the top to get started. Let's assume that the main application is myapp.jar and it has some helper code in mylib.jar. And let's assume that the cloud of third-party jars, that filling in the sandwich, can be simplified to just Jackson, the JSON processing library. Jackson comes as 3 jars: core, data bind, and annotations. Of course, to run the application today, you have to ensure the class path is set up like this. Everything's in the lib directory. I'm going to have my things first, and then the Jackson jars, and then my main class. No problem. JDK 8. Now, you wouldn't have to bother with that long invocation that sets the class path to this and that and the other if myapp.jar and mylib.jar turned into modules. Now, turning each jar into a module one for one is a fairly natural way to proceed. It's not always possible, especially if jars have cyclic dependencies among their classes, but let's go with it for now. Whenever you see a module, you should ask 2 questions. What does it require, and what does it export? Let's ask that for each of our prospective modules, myapp and mylib. One way to find out what a module might require is to run jdeps on the jar file that you have. Jdeps is a tool in JDK 8 that analyzes classes in jar files and finds whatever classes they refer to in other jar files. Here are the results of running jdeps on myapp.jar and mylib.jar. The classes of myapp.jar make use of classes in Jackson core and Jackson databind.jar, and of course in mylib.jar, that's the helper. Plus, myapp.jar uses classes from the Java base module. I'm pretty sure Java-lang object is among them, since that's down in base, and string is another one. And for sake of argument, it uses Java SQL as well. mylib.jar turns out to only use classes from the Java base module. So that's nice and simple. The arrows are, my app depends on all sorts of things, and mylib, and then mylib is just, for sake of argument, depending on the JDK itself. So with this knowledge, we can write the module declarations. Here's the moduleinfo.java file for mylib, our helper library. All it requires is java.base. Now, you never actually need to write java.base, since it's literally impossible to write a Java program without indirectly relying on Java-lang object. So we always give you the dependency on Java base for free, even if you don't write it in source. But we put it out here to be clear. Now, there's an exports here which I've written by hand. JDEPs cannot realistically help you determine the exports of your jar. We could just say it exports everything, but when you're writing the module declaration, you still have to choose. So let's say that mylib exports a package, com myapp libutil, to the myapp module we're going to make. Now, this is a qualified export because it's specific about which other modules, namely myapp, can access this exported package, in particular the public types of that exported package. Let's now turn to the moduleinfo.java file for myapp. It requires mylib, our newly created module, and it requires Java base and Java SQL. And of course, we know that it's going to use Jackson. So we'd like to write requires Jackson core and requires Jackson data bind. Does that mean that I, as the developer of myapp, have to write moduleinfo.java files for Jackson as well? That would be a pain. I don't control those jar files. If only there was some way for the Jackson jar files to become modules automatically. In that case, we could then write the declaration of the myapp module, moduleinfo.java, like this. We just require those jars like any other module. We would have a beautiful module graph with myapp depending on mylib, those are two explicit modules, and myapp depending on some of the Jackson modules, and then also down on JDK modules. You can do this. The solution is automatic modules. An automatic module is a jar file that you put on the module path rather than on the class path. Once you do that, you have a real module. You don't change someone else's jar file. You don't change its manifest, you don't put any class files into it. The name of that module is derived from the jar file name in a fairly obvious way. It strips the version off the end and other things. That automatic module exports all of the packages. Like I said, there's nothing else you can do, really. It exports all the packages from the automatic module. And that automatic module requires all other modules that are in the system. So, in effect, automatic modules mean that today's jar files that you're running on JDK 8 are tomorrow's modules. They can act as modules in JDK 9 very often without you doing anything. Without you doing anything to them, rather. So once automatic modules spring into existence for Jackson core, Jackson data bind, and Jackson annotations, the module graph looks quite different. The automatic modules basically require everything. That's a feature, not a bug. They require each other, they require all the modules in the JDK image, and all of your modules, look, the arrows are going up as well. Now this is to provide the maximum possible compatibility surface for code in older jar files. You might think that the module system could run JDEPs on the jar files, those 3 jar files, at startup and try to figure out what modules they require, but that wouldn't really help. And the reason it wouldn't help is a bit subtle. The thing is that the libraries that you typically find in the filling of the sandwich often make use of core reflection, that is the Java Lang reflect API, and they use it to inspect classes dynamically. Now, JDEPs can see the invocations of the core reflection API, but it can't very well predict statically what classes will be inspected dynamically. And in fact, the Jackson data bind module makes exactly this use of core reflection. When code in my app, here it is, doing an import of the Jackson API, and then calls the Jackson API object mapper, it passes, there it is, the final argument, it passes its own class object. The intent is that Jackson data binds can create an instance of the myValue class, which is an application class. Why? So that it can then assign the field name to Bob and age to 13, because it's doing JSON object mapping. Now, on JDK 9, this code won't succeed because we never actually got round to saying what the module myapp exports. Myapp doesn't really have an API. It's the top node. It's the application. Yet, it needs to export some packages anyway. And you may find, if you're using any frameworks at all, even if you don't think as an application that you have an API that other people call, you have this implicit API anywhere you add it at inject, right, or at entity, or at path param, or you pass any of your own class objects down to a library. The solution is to declare myapp as a weak module. A weak module exports all of its packages in a way that allows a framework like Jackson Data Bind to reflect over its internals. You do not need to manually export the packages one by one and then keep this module declaration up to date with the source tree of myapp. With a weak module in effect, you get the benefit of reliable dependencies, but without the full strength or the full power of strong encapsulation. Frameworks that reflect over application code are a reality in everyday Java development, and they aren't going away. So application code like myapp can't always be strongly encapsulated. There is business value in the frameworks that call back into you reflectively. So we think this weak modifier at the very beginning of a module declaration is a clear statement about the nature of this module. It's open for reflection, but it doesn't have an API. Without the weak modifier, a module is strong. It explicitly defines an API via exports statements. So let's come back to the module graph. It is pretty messy, but it's better than when everything was a jar on the class path. And by the way, because myapp is now exporting what it needs to, that arrow that says data bind is going to require implicitly myapp, there's that, and then there's the export from myapp because it's a weak module, and all the reflection from data bind will just work. But the overall graph is still pretty messy. But better than the class path because, for example, there is no arrow from mylib to myapp. So there is no danger of code in mylib accidentally reaching into myapp's internals. On the class path, code in mylib.jar could access code in myapp.jar quite easily. It's just scan the class path until you find the class. And that kind of chaos is what causes maintenance headaches down the road. In fact, if you think about it, the class path, at the end please, the class path is crazy. With just 10 jars, you get 100 possible ways for classes in those jars to interact. The class path is the ultimate in erasure. Whatever you know about the structure of your system, the class path throws it away and connects everything to everyone else. And that means conflicting classes and missing classes and duplicate classes in different jars, and generally slow sequential lookup every time the VM needs a class, which is often. With modules, you're telling the compiler and VM about the structure of your system, and automatic modules, there is a tension between the cleanliness and the usability, but it all works out. You're telling the compiler and VM about the structure of your system, and finally, they make use of that information. Speaking of the compiler, let's see how you run it for these module declarations I've been talking about. We've got the JAX and jar files in the lib directory, where they always were, and we're going to treat them at compile time as automatic modules by putting them on the module path to the compiler. Then we've got the myapp and mylib source in the source directory. And we tell javac about that directory with this new module source path option. And that's necessary because there's a new level in the directory hierarchy for the modules. So we go, you can see source myapp and mylib are a new level in the traditional compile time hierarchy, so that we can put in source module name and then modulinfo.java, and then the package hierarchy at the same level as modulinfo.java. The result then is class files -d in the mods directory. We can run jar to build mylib.jar based on the classes in mods mylib. We can run jar to build myapp.jar from the classes in mods myapp. And because it's going to be the main class, we specify that on the command line here. And then because these jar files have modulinfo.class files in them, compiled from the two modulinfo.java files, we call them modular jars. Modular jars is a term you will hear a lot in the succeeding talks in this sequence. So you can then run the modularized application with this simple command line. All the stuff passed to -cp in the past is now wrapped up in the modulinfo.class files. The explicit modules are in mlib. I think I moved them there from mods. And the automatic Jackson modules are in lib, where they always were. And so that's it. So we modularized an application with two techniques. First, we built modular jar files for our own application code by writing and compiling modulinfo.java files. And we also created automatic modules for third-party code, for library code, simply by putting their jar files on the module path, passing that lib directory to module path rather than to class path. So if you like, you can think of this as top-down migration. I wrote the module declarations for the application and then kind of worried about what was underneath it later. So if I say top-down, you should think, what does bottom-up migration look like? And for that, I will hand over to Alan.
Library migration. So this is the second part. So we will roll back to where we were at the beginning of the presentation, where we had the modular platform at the bottom, our sandwich of jar files in the middle, and our application, and whatever libraries it comes with, at the top. So what we're going to do is we're going to start at the bottom now and try and move the Jackson jar files that we have. We want to move and migrate those to modules so that we end up with this picture. Green is module. Orange is the class path. Exactly as Alex did in the first part of the presentation, when you're migrating and you see a module, you have to ask us the questions. What do they require? What do they export? So for each of our 3 Jackson jar files, if we're going to think of them as modules, we need to think about what do they require and what do they export. We'll start by running what we call the JDEPS tool. So if you're at the earlier talks, you will see that we use the JDEPS tool to actually do some static analysis on existing libraries. Alex used it in his part of the presentation to look at myapp and mylib. We'll do the same thing with the Jackson jar files here to understand what they require. So we see that the Jackson annotations jar file has code in there that makes use of types that are in Java base. That makes sense. Jackson core also has some code in there that makes use of some types in Java base. Jackson data bind is much more interesting. There is code in that jar file that has references to types that are in Jackson annotations. There's also references to types that are in Jackson core. There's also a couple of other references to types that are in Java Base, of course, Java SQL, and Java XML. I should say is that when you're trying to understand what a module depends on, you don't need to, of course, use the JDEPS tool. There's other ways. If it's a Maven project, then you've already got a POM, and that'll give you some idea what it depends on. So this is the dependency graph from the JDEPS output, and just keep this in mind because we will be coming back to it in the later slides. I'm now going to run JDEPS again, this time with a new option, gen module info, which is a way basically to get your starting point or your starting module info.java. Now, in the earlier talks, we had JDEPS being usable on JDK8 to be able to look at your jar files in your applications that you're using with JDK8 and older. The version of JDEPS that's in JDK9 has a bunch of additional options that aren't available in the 8 version, and this is one of the command line options that is new in the JDK9 version. When you run JDEPS on a bunch of jar files with the gen module info, it will generate you a starting Java info, or sorry, module info. So I've run it on these 3 jar files, and it has created me 3 module infos, one for each of the jar files, and we'll look at that in the next slide. So for Jackson data bind, which is probably the most interesting one in this set of jar files, this is the module info that the JDEPS tool created for me. There's a bunch of requires at the top that is based on the static analysis of what's in the jar file. And JDEPS has no idea which parts of the jar file are in the exported API and which are internal. So it assumes that every type is part of the API, therefore every package is exported. So it generates a little exports directive for every one of the packages in the jar file. If you look closely at the requires, it also looks at the signature of the methods that are, and that's able to determine whether to generate a requires or a requires transitive. So in the previous talk, we talked about requires transitive, so here you're seeing an example of it in a generated module info. For this part of the talk, assume that we are the maintainers of this library. So we have much more knowledge about this library than JDEPS does. So, and as maintainers of this library, one of the things we will want to do is, or not want to do is, we don't want to be exporting our impl packages. That's where our internal implementation is. It's not part of the API for this library, we'll assume. So what I might do is I might edit this generated module info and delete the exports that don't make sense. So JDEPS generates me a module info where everything is declared as being exported, but assume as maintainers that we know better and these impl packages don't make sense. So we will delete these as part of creating the right module descriptor, right module declaration for this Jackson data bind module. Now we'll do similar to what Alex did, and we'll start to compile this. So what I've done is I've generated these module info into the source tree for these 3 modules that I'm going to compile. Remember, with our modules, we have an additional directory now in the file path that is the module name. So all my source code for these 3 modules is organized src/module name, and then my traditional hierarchy of classes organized by package in that tree. My module info is in the top level directory of each one of the modules. So for Jackson core, the location of the module info is src/module name Jackson core/module info.java. Same for the other 2 modules. I'm now going to compile all of these 3 modules together. So I'm recompiling all of Jackson in this case, all 3 of them, and I'm doing a multi-module compilation. So with one javac command, I'm compiling all three modules together. I'm giving it an output directory of mods. That's where all the class files are going to be generated. And the input to it, I'm just giving it a find command where it'll find all of the Java source. So that will compile. I've now got a mods directory with 3 directories in it and all of the class files. I'm going to run the jar command 3 times, and because I'm going to create a jar file for each one of my modules. These are modular jars. The options you're seeing on here is new options on JDK 9. So the jar tool has historically had very obscure and very uniquely Java options, a bit like the zip tool, some of them. They've been modernized in JDK 9, particularly to use the GNU style format, or at least close to it, as you saw that, and maybe in the introduction talk earlier on with some of the other tools. So the jar tool has -- options, so -- create and -- file. So I'm creating a jar file. I'm telling it what jar file to create. This is a modular jar. I'm going to create it in the mlib directory. I'm naming it Jackson Core and a version number. And I'm telling it the location of the class files I'm going to package in, and I'm creating 3 modular jars. So that's really, really nice. Exactly as Alex did with my app and mylib in the first part of the presentation. Now this is what we've got now. So we've recompiled Jackson Core, Jackson Annotations, and Jackson Data Bind. We've packaged them up as modular jars. This is the module graph that we have. So the platform modules at the bottom, and then our 3 Jackson modules as explicit modules. Their dependencies are clear, their exports are clear. This is a nice module graph. Just to recap how we ran these on the class path right at the beginning of the presentation. We're now going to change this command so that we're running with these 3 libraries as modules. So that's the old command. Now we've got the new command. So for those that attended the intro talk earlier on, I talked about how to mix the module path and the class path together. This is exactly a scenario where you have to do this, because my app and mylib are on the class path. Our 3 Jackson libraries are now modules on the module path. So there's both a module path and a class path specified to the Java command here. My 3 Jackson modules are in the mlib directory, and I'm specifying the mlib directory to the module path option. My class path has my app and mylib, so I'm specifying those with the -cp or -class path. But exactly like the intro talk earlier on, there is nothing to say in my app or mylib to say that they depend on Jackson Data Bind. There's no dependency information available on the class path. So I'm having to help the runtime with the add modules option to tell it to resolve the Jackson Data Bind module. This is one of the complications when you're trying to mix the class path and the module path together. There's nothing on the class path to tell you what the dependencies are. So I'm helping the runtime with the add modules option to tell it I need to resolve the Jackson Data Bind. So that is the command line that I've ended up with modules on the module path and my application on the class path. Questions at the end? Right, so now we're going to put it all together. So I've got modules on the bottom. I'm going to take the modules that Alex generated in the first part of the talk, and I'm going to combine everything together. This is what we have for the second half. Now we've got Alex's modules with my app and mylib, and we have this nice module graph. Everything is green, everything is modules. It's very, very clear what the dependencies are in this graph. So now let's go and run this, now that we have everything as modules. Just to recap, everything is modules. So if I look in my mlib directory, I have 5 modular jars: my app, mylib, and my 3 Jackson modules. My command to run this has shrunk because I'm just telling it the module path and the initial module. The initial module, our main module, is my app. So I'm going to ask it to run my app. That will resolve what does my app depend on. My app depends on mylib, depends on Jackson data bind. We will generate the transitive closure. All of these modules will get loaded in order to run my app. We can go further. So if we combine, in the intro talk, we had some simple options or some simple examples using JLink to create runtime images. Now we have our application and the Jackson libraries as modules. We can actually do the same kind of thing. This is the advanced talk, so I have a couple of advanced options on the JLink option. So what I'm producing here is a runtime image that will have my app and all of its transitive dependencies in a runtime image. So this is something that can be distributed with just the modules that it needs. So the options I'm giving to JLink, just like Java-C, just like the Java launcher, I'm giving it the module path as to where to find the modules. I'm using the add modules option, telling JLink what modules I'd like in the runtime image. JLink will generate the transitive closure and link all of those modules to create the runtime image. I want a relatively small image, so I'm giving it some options to do compression, to do some stripping. There's, like any linker, there's much more complicated options I could give it to do other customizations of the runtime image, but I'm just sticking with the size for now. And what I ended up with is a runtime image that is, in this case, it's 26,000, yeah, so just about 25.5 megabytes. If I look in the bin directory, I see in there only a small set of tools. The Java launcher, I see something for my app that has been generated by the linker. If I run the list modules option on this generated runtime, then we see that it has, this is the list of the modules that are in that runtime image, my app and mylib, the Jackson libraries, and then in this case there's 4 platform modules that have been linked in. So this is quite nice. I've ended up with a small runtime that for my application. And I can just run it with this. There's no module path specified because they're all linked into the runtime image. I can just do java-m my app, and my application will run. In addition, the linker will generate a little launcher script for my application as well based on the module name, so I can make the command line even shorter if I wish. And that is a quick run through of things from the bottom up and then combining the modules that were generated from top down, so that everything is modules, and then we go further and actually create a custom runtime image. So the main thing we've got through in this presentation is, I hope that we've actually demonstrated, is that you have the freedom to adopt and migrate to modules at your own pace. Alex has shown how to migrate and modulize applications before the libraries have been migrated. It's possible, as we saw in the second half of the presentation, to modulize libraries completely independently. In addition, you've got a flavor for the different kinds of modules. So Alex started off with explicit modules for my app and mylib, and then made use of the Jackson libraries as automatic modules. So that gives you a flavor of explicit versus automatic modules. And also showed you one of the current proposals on the table, which is weak modules, and how that they can be actually used as well for, especially for applications that don't export any APIs. So hopefully that has given you a flavor of what's there to support migration to modules. So we'll just finish up with a nice catch line and go forth and modulize. So we have a couple of other sessions. We're mostly in this room. So this is our third one today. We start into the repeats of this tomorrow at 2:30. But the important talks that haven't been done yet are the modules and services at 11 tomorrow. And then Alex is going to do Project Jigsaw Under the Hood at 4 p.m. tomorrow. There's also a hack session, which is, you can think of, bring along questions, bring along your laptop if you want to try things out. That's on Wednesday at 8:30. One of the rooms here, I'm not exactly sure which. and that's a 2R. And more information. So this is the link to the Project Jigsaw page where we're working on the implementation of Project Jigsaw. There's also a link to the mailing list and where the early access builds. Let's see. So as I said in the other talks earlier on, is JDK 9 is still in development. It doesn't ship, and it's not scheduled to ship until next year. So many of the things that we're actually showing here are things that are just not final yet. Nothing is final yet. There's still JSRs, there's still discussion, there's still early access. Everything is still in progress. So what we've shown here, maybe the final JDK 9 isn't exactly like that. So I think we've got about 10 minutes for questions. Actually, we've got 15 minutes if people have questions. So protocol for questions will be, if you can make it as far as the front, then call into the microphone so that people can hear us. Otherwise, we'll have to repeat the questions. So Mark is available for questions as well.
Please come up and use the mic. We're not going to repeat your question.
We can't hear it.
We can't actually hear. Yeah.
In the first one, with the automatic module, Jackson automatically depended on the My App, which allowed it to do the reflection. In the second one, how does Jackson reference the My App?
You should stand up at the...
Oh.
Especially considering Jackson probably isn't something we are able to modify.
This is a good question. So the question is, I was wondering if someone would spot this. In the first part, when Jackson data bind is an automatic module, it's requiring implicitly actually my app and my lib, because it requires everything. But then when Alan modularized it, all the way, putting it all together, the arrows are all down. Yes. So the thing is, so data bind is using core reflection to access the classes, the exported classes from my app. My app passes a class object to data bind. That was in the that's in the data bind API, and that means the code in data bind can access all, as long as that class is exported from my app, data bind can reflect over it. It doesn't need, it actually gets an arrow for free going back up to my app. Even when data bind is an explicit module with a module declaration. But clearly it doesn't know what modules it will be, what classes in what modules it will be reflecting over, so it can't possibly say requires them. When it reflects over them, as long as the class is exported to it, the reflection just works.
Okay.
Which, if you're paying very close attention, is a change from last year. But pretend I didn't say that. It just works.
Cool.
Yes.
All right, thank you.
It's a good question.
Once I modularize and link and create the image, and if I decide to upgrade one of the jars, do I need to start from scratch for that jar or for that module to rebuild the image? Or how do I manage the version upgrades of individual jars?
Right. So I think what you're asking is, do you need to rerun the JLink command?
Oh, I need to rerun.
Yeah, exactly. And JLink will actually record all the options that are actually used to make it easy to rerun it if you have new versions of the modules.
I was wondering if you could quickly go over again what required transitive exposes about.
Which we didn't say, but okay. So the question is about what's different about requires transitive versus requires Java logging. The full answer is in Jigsaw under the hood, but it's not a complicated feature. It's not an advanced feature, so fair question. So you'll see Jackson data bind requires Java logging. Logging is an implementation detail of data bind. It's just calling logging's methods. It's not exposing it in any way. But data bind requires transitive Java XML. Now, I haven't looked at the data bind Java doc in detail, but what the requires transitive Java XML tells me is that the way that data bind depends on Java XML isn't for just an implementation purpose. It's because the API of Jackson data bind, somewhere in all these exports, has in a public signature a type from Java XML.
Yeah, so if I write a module that
Yeah.
requires Jackson data bind,
Yes.
what do I get from Java XML?
Right, so if you write a module that requires Jackson data bind, the fact that data bind says I depend transitively on XML means your module, you could say requires Java XML, there's nothing wrong with that. If you don't, it will be as if you had said requires Java XML. What do you get from Java XML? Whatever it exports, everything.
All right, so that's what I was wondering.
Yes,
Get
it's,
everything.
it's how you get modular granularity dependencies while still allowing refactoring.
Thanks.
By the way, there's a couple of slides on this in the intro talk from earlier. You may have missed that, but you may want to catch up as well.
Two questions. One is, say you've got 3 third-party libraries and they were all built with slightly different versions of Jackson. So different parts of your application maybe even Yes,
using different versions of Jackson.
but they're compatible. They're just slightly different bug fixes, for example.
Pick one.
Yes. Okay, so you pick one. Does that mean everything else will still pick up the version you've decided to pick?
Let me ask another question. Your application, it's not your code necessarily,
Yes.
but transitively uses different versions
Yes.
of Jackson.
Yeah.
How do you put those jars on the class path in JDK8?
Well, at the moment, you specify them explicitly.
But if you specify version 1 of some third-party jar and later on the class path version 2 of,
Well, no, you pick one explicitly.
then we're done, right?
But it's still in the class path. You're saying now that you don't use the class path.
If you don't, so you don't whatever you used to put on the class path, you would now the exact same jar that you picked to put on the class path, just put it on the module path.
All right, okay. So it's
Yeah,
different.
and then it magically, really it's magic, just becomes an automatic module
Fair enough.
with the name, and we drop the version qualifier
Right.
according to some heuristic that's in the Java doc. So these are the real module names that you
Right.
get from the real jars.
Yes. And I guess, will there be something like a Maven build plugin for it?
The Maven
Mr. Maven
chief
is behind you.
is behind you and has an entire talk about that.
Okay, fantastic. Thank you.
Hi. Once you've upgraded an existing library to be a module in the new system, is it still possible to compile it using the class path rather than the new module?
So if you, let's bring the applicant, let's bring it up. Let's bring the Java C invocation. Right, so here we are recompiling the library for JDK9. Right, so this is the source, this is the library source. I'm going to compile it, put it into the mods directory. The class files that come out of this will be version 53 class files, Java SE9 class files. Clearly they won't run earlier than JDK9. What you can do, did you show this in intro? We were going to put
Not
this
an
in
intro. I was going to actually show it
We were
on
gonna- we were gonna
Wednesday.
put it-
Right. So there's. It's
So what you can do is compile the source once with -release 7, for example, and then compile again just the module info.java file, or files in this case. Don't specify -release, the default will be 9. So that will give you class files where module info.class is version 53, which it has to be. The rest of the classes from the 3 source trees will be 51. Run them through jar.
Okay.
The resulting jar files will run on 7 and 8.
Yeah, let me clarify my question. Say you're compiling for Java 9.
Mm-hmm.
The reason I ask this is there's a lot of existing build tools that use class path that will not understand what modules are. So if you just drop in
Yeah,
a new version.
if you're running on JDK9, the class path will still take modular jars, just nothing will read the module info.class files.
Right, so it'll just act like an automatic module.
Right, with all of the the n factorial
Yeah.
Dependencies.
right.
Alright, yeah, that was my question.
Yeah.
Just to clarify what Alex said is you can take a modular jar and you can put it on the class path, and it'll just work as a library on the class path as it would have always done.
Yeah, thanks.
But I would, in the nicest possible way, question why you want to do that. If you're running on JDK9 and you've made a module you've written modular.info.java or you found one, why you would then want to put it on the class path on a JDK 8 installation, clearly. But on a JDK 9 installation, I'm trying to work out what you're trying to do.
I wouldn't personally, but there's a lot of automated build tools out there that generate class paths. And so if you like upgrade one of those to a new module, you still want it to work with that build tool.
Yes, yes. In time, though, I think you would expect the tools will eventually add support for modules.
Yes, absolutely.
Yes.
So I have two questions. One is I'll start with a follow-up to his, which is it appears that if you put a module on a regular class path in JDK 9, you're actually breaking the protections, the access protections.
Yes.
Because, so the access protections are actually not as tight as they may appear otherwise.
On the class path, there is no such thing as a modular jar on the class path. They're just jars.
Right.
And because they're not modular jars, we're ignoring modular.info.class, we're ignoring the exports.
So there's no way for a publisher to kind of bake in the protection into, it's only protecting the runtime as you configure it, but the publisher cannot actually protect.
That's correct. No,
That's true. And if you're in control of the on-disk layout, the on-disk placement of jar files, you are in control of everything, even if the modular jar files are put on the module path. If you're controlling the command, if you're controlling the environment, you can just say ---- add exports and decide that you wish to, as the system configurator, overrule the exports in the modular jars.
Okay.
You can do that.
Okay. And the other question is, in your first example, we're using legacy jars. If I wanted to protect my app for not being a weak module, then I could actually have a qualified export to Jackson.
Yes.
And that'll work.
Yeah,
Basically.
so if you don't say weak, the default is that the module is strong. You then have to enumerate your exports. You can choose to have them being exported qualified to, not just to Jackson, but to Jackson Databind in particular.
Yeah.
Yeah.
Yeah. And the rules for reflection and regular access are basically the same.
Exactly.
Okay.
They are dominated by the exports that aren't on this slide because they're implicit, but
Yeah.
Yep.
Okay. Thanks.
I have a question is, so in future, are you expecting those providers to expose module or jar?
We are hoping that framework developers like the Jackson developers will write module.info.java files for their code and produce modular jar files. They're still jar files, but they have this module.info.class file in them, so that on JDK 9, the runtime knows to do the strong encapsulation.
Okay, but I noticed you have a feature here. So for a jar, the public doesn't mean they will expose that interface, right?
So
even that class is public.
that's right. So if you look at the crossed out lines, so confoster XML, Jackson Databind, DSER, impl, that package I'm pretty sure has public types in it.
Yeah.
Those public types will only be accessible within the Databind module.
Okay. Yeah, my concern is they expose their module, so they define which should be exposed. But when another provider, they might use this jar, but they define their own module. Then they expose this one. When you use it, even they are in the same version, but you don't know exactly what was exposed.
I'm confused, sorry. It's amazing. In some ways, it's always so simple when you look at the artifacts, but he did this and she did that.
Yeah,
so,
just like a version confliction.
Well, so don't bring versions into this. You're saying that, so here's Databind that has chosen to export a particular API. right? The author of data bind is saying export the first 4 packages, and then there's another one, etc., etc. You said another module, another one. Someone else wants to do what?
For example, Jackson data bind,
Yeah.
they use the Jackson annotation.
Mm-hmm.
When they define the Jackson annotation module info file, they say they expose this class, right?
Okay.
So this was used by data bind. But another class, maybe my application, I also use the Jackson annotation. But I decided to use another, the same version of annotation, but I decided to, I don't expose this class. Then another one, they use my application. They also use Jackson data bind. When they look at the module information, they will see the same information because they use the same version. Then they randomly pick one, but then they don't expect what's the real result.
I understand you're saying that the Jackson annotations module, one version exports a package, and another version of Jackson annotation doesn't export the same package.
Okay.
That's your scenario.
Yeah.
I think that's a little unusual. That you could imagine it happening, but let's assume it happens. Jackson, whoever is picking the version of Jackson data bind to go on the system, because my app requires it, also has to pick the version of Jackson annotations that very first requires clause will resolve against. There's only one version of anything on the system.
Yeah.
If there are 2 versions of Jackson annotations, pick one.
Yeah, because I think it's a good feature to have those decide to expose which class or which package. But but I still think I have some concern on those conflicts.
You can't do it on the class path today.
Okay.
You can't do versions on the class path. If the next 5 questions are about versions, it's still going to be pick one.
Okay.
Sorry.
Thank you.
Thank you. Okay.
So you've shown how to do top-down when you're the application owner. You've shown how to do bottom-up when you're a library developer that has just Java modules dependency. What's the story if you're in the middle? So you have a library, you'd like to move it to be a module, but sadly, some of your dependencies are not yet modules. Should you do it, or should you wait until the graph underneath you is clean?
You should do it.
Yes.
Okay.
You should do it, and you should document. And when you do it, here, let me bring up data binds. So if data bind required Guava, for example, and Guava is not yet an explicit module, you are presumably testing your library against some version of Guava. You can write requires Guava in here. I'll assume it's not exposing Guava types and signatures. And you need to put in your documentation that please put Guava, download some version of Guava, and put it on the module path. Because you are being a good citizen, but this is the issue of issues. If you wait to modularize, then some other library, it's a complete tragedy of the commons.
Right.
And
The
so
important thing is that libraries can actually migrate independently. That's really what the first part of the presentation.
I guess there is just a small tie-up in the way you end up, the modules end up being named, so you need to pay attention.
I was going to say, the next question that people then ask is, okay, I'm data bind, I'm a good modular citizen who hopes to be linked into an image one day, that would be nice. But I require Guava, and Guava is working as an automatic module on my system and therefore everyone's. What about when the vendor of that module, of that jar, makes it into a modular jar? When they declare a module, and they decide to call it something else. That would be impolite of them.
Okay, so in a way, the name that your jar has today, and the way you have automatic naming should be respected and be part of the public API.
We should.
Okay.
You should be giving this presentation.
This is a great trick, but we think it will be a powerful.
Exactly. Was there another question? Oh, here you are. You're here. Okay.
Sort of similar question.
Uh-huh.
So the second question I had is much simpler. So I missed the intro talk. So what I understand from here is if you're just a regular, application developer, which just depends on libraries like Jackson and stuff. So then probably you should just do the top down, which seems much less work, and it's just if your app is there, you just have to declare it as a week. So that's the con side. But then if you just do top down and get up and ready, at least for your your app to be modularized, and that should be good enough to go.
It is very common to be able to download a jar from the internet, such as Jackson. They might be JDK 5 or 6 era class files in those jars. Put the jar on the module path. It will very often work as an automatic module, which gives itself a name it springs into existence so that your module info.java in your application can require it. That works surprisingly often. And if it doesn't work, don't call us. Call the author of, and I can tell you some of the reasons that they are either accessing JDK internals, which is nothing to do with the modules. It's not really the module system. It's not automatic modules that are the problem. They're accessing some internal thing, and their jar won't work on the class path either. If they're not accessing JDK internals, you occasionally find traditional jar files that contain classes in the JavaX annotation namespace, in the JavaX XML registry namespace, and so on and so on. They should not be including those classes, but they do, and the module system at startup detects that there is some package that has classes in the JDK image, classes in this automatic module. That's a bad thing. Something funny is going on, so the system will stop.
I see. Okay.
And if that happens, don't call us. Call the creator of that traditional jar to say, why have you got Java SE types in your random jar file?
I see.
That's never been a supported thing.
Right. So there is still that class naming conflict on that.
There can be. It's actually relatively rare, but when it happens, you are in trouble. Someone else has got you in trouble.
Yeah, makes sense. Cool. Thank you.
Thank you. One more question.
Yep, I think so. We'll have to wrap up then in a minute.
Last question.
My main question is, outside of like smoothing over some of the class path issues that you can have while you're doing Java development, is there any other benefits that these modules will give you?
Are you developing, is your jar an application jar that no one calls, or is your code a library that lots of other people call?
I have both.
Okay.
So.
How many jars are there in your application?
I'm
Some.
looking at, there's probably maybe 30 to 50.
Just in your application?
Yeah.
How do you track the dependencies of code between classes in those jars?
It gets messy.
Is it a big ball of mud?
Yeah.
That's what the JDK used to look like.
Okay.
The ability not only to express, the ability in a module to say not only what it depends on, but also what its API is. Now, there are some jars at the very top of the graph that don't have an API. They got the main class. But for everyone else, there's an API that it is worth declaring explicitly. You can declare, these exports are to everyone. If you have a nest of jar files, you can export to your friends. And what that means is you will never again, it's an investment you make once. And once you've made it, you will never backslide into, why is he, are you the business partner? Why is he calling this type in my package? It was meant to be internal.
Yeah, but shouldn't you have just marked it protected at that point? Or
Protected is a whole mess of access control complexity. In order to share anything between, sometimes you want to share between packages with public.
Yeah.
You want to share with him. Other times you have types in you have a package that you don't want to go outside a jar. I'm pretty sure you have at some point said, this package is just for other packages in the same jar file.
Right.
That's it. That's what the module system gives you.
Okay. All right. Thank you.
And by the way, on the ball of mud, we had the slide showing that in the intro talk earlier.
Well, the ball of mud is kind of, that's a ball of mud. It's very clean, but it's
very symmetrical. Okay, I think we're done. We're wrapping up. Thank you.